All right, how's everyone doing? We're just going to go over, some students asked for me to go over the note where we graphed sine, cosine, tangent. So I'll kind of just go over the key points that hopefully you got from that. So if you remember the note, it had you kind of plug in values between 0 and 360, and you plot them on a table, and then you graph the points and you see what they look like. So here, I mean, don't get too caught up with this part here. I want you to use like special triangles to find the missing values. So here, like if this was 30 degrees, that's root 3, that's 1, that's 2, right? So then you'd have sine of 30 is opposite or hypotenuse, right? You do cos of 30 equals root 3 over 2, tan of 30, opposite over adjacent, like that. And then you would plug them onto the next screen here, and you would put in the value. So, 1/2 is the exact value, the decimal is 0.5. And you pretty much filled in all this stuff here, and then you plotted them. Now, when we graph, we're not going to graphic this again where you're going to have to plot like 20 different coordinates. Really, when we graph sine and cos, we only really care about our key points, which is going to be at 0, at 90, 180, 270, and 360. Now, like I made you fill in all of them because say like you didn't know what it looked like. Then you'd be like, oh, cool. Okay, I'll plug in these values, draw the picture, and then see. Now, like we know what it looks like. So then I'm just going to use these 5 key points to graph any sine or cosine graph in the future. So if we scroll down here, when we graph it, all right, so eventually all we're going to do when we graph, so when we filled these numbers in, if you refer to your note and the solution that I posted online, right? If you plug in sine of 0, you get 0, right? So I get 0 there. So I'm going to put a dot there. Now, again, I don't care what these values right now, because when we did sine of 90, you got 1, right? So the exact value and the decimal are the same. So where's 90 up here? So I'm going to put a big dot there. When you did sine of 180, right, you got 0. So then I put a big dot there. 270, you should have got -1. So let me just put a dot there at -1. And then when we got to 360, you should have gotten sine of 360 is 0. Okay. So these are my key points. And then now we know what it looks like because you've graphed the table of values that had many more points. So like if you just saw these coordinates right now, right? Like you'd be like, oh, yeah, I'm just going to draw like a straight line, straight line, straight line, straight line, and there we go. But that's not what it is. It's not a straight line, right? When you graphed all the coordinates, you notice that what you get is right, this curved line, right? It goes down like that. Oh, I don't want you to be like that. Come on. right? And then there we go. So I have this beautiful kind of wave, all right? So when we have to graph these, and we'll worry about this really more next unit, right? Like I put a point there, I have my key points, draw myself my nice wave, and then I'm good to go. Okay, just notice also when we look at my graph, right? Like I'm going to break this up into 4 chunks. Because remember when we talk about the cast rule, right? I can swing my terminal arm into 4 quadrants, right? So I mean this is quadrant 1. Now if you remember in quadrant 1 sine is positive, and obviously if I look at the graph here, sine is positive. Okay, because if I look at the values on the y-axis here, they're all positive. Quadrant 2 is right here. And if you remember, in quadrant 2, sine was also positive, okay? So it's above the x-axis. And then it's not until quadrant 3 and quadrant 4 that sine is negative. And you see that here from the graph, right? Sine, this part here is negative, all right? So again, so when we graph, again, I want you to just focus on these key points, 0, 90, 180, 270, 360. And then for the regular graph of sine, right? Because again, this is like a sine graph with no transformation, right? This is like just sine theta. What we're going to do is we're going to add variables to it to stretch it, shift it, move it around, okay? So if I do that same thing, we go over cosine, right? So again, cosine, I'm going to worry about this point, right? 0, 90, 180, 270, and 360. Okay, and when you type all that stuff in and you look at your what you got on your as you've worked on this note during the week, right? If you typed in cos of 0, oh sorry, not 0. If you type in cos of 0, you should get 1. Okay, so then I'm going to have a big dot up here. Cos of 90, you should have gotten 0. So then I'm going to put a 0 down here. And then sine of, or sorry, cosine of 180, you should have gotten a negative 1. So I'm going to put at 180 a negative 1. And then hopefully by now you see the pattern, right? Like cos of 270 is going to be 0. Cos of 360 is going to be 1. So I'm going to have a point here and then a point here, okay? So again, now what we're going to do when we graph this, right? This is not, we're not just connecting straight lines. This is going to be a nice little wave. So I'm going to curl this down like that. All the way, oh, come on. Here, I'll just change my pen to a regular color. All right, so here, this is our cosine graph. And again, when you look at the breakdown, right, like these are my different quadrants, right? All right, and then when I look, if you remember from the cast rule, right, where was cosine positive? Well, cosine is positive in quadrant 1. And obviously I look here, the cosine, the graph is above the x-axis. and cosine was also positive here, quadrant 4, right? And we knew cosine was negative in quadrants 2 and 3. Okay, so again, when we graph it, right, we're going to focus on these points, right, my key points. And then I remember what the shape of this looks like, right? I just draw a nice wave, and then that is it. So our key points always, let me just add this at the bottom, right? Oh gosh, hit that button again. Sorry, guys. Come on. Sorry, my computer is going. Oh, there we go. There we go. So, oh gosh. Yeah, so the key points are always at when theta is 0 or 90, 180, 270, and 360, right? For when we look at sine theta or cosine theta. Okay. So now tan is weird. I'm going to just, like, I added tan because normally if we had a regular class, then we kind of look over tan and talk about how messed up it is. I'm just going to ignore it for now because you really don't have to worry about tan at all. Okay. We will never graph it. And if you want me to, talk about tan, then you can send me a message and I can send you like a video about tangent and why it's weird. Okay. And you can also look at the note that had all the filled in answers. Okay. So here, this part is just filling in the table where you talk about things that we have discussed, like, domain and range. So like the domain for sine and cosine. So notice that we used only a small sample of the possible values for theta. Okay, so what can theta be? Well, like the domain, y equals sine x. X can be any real number, right? Same with cosine. Okay, this we'll just ignore. Who cares about tan? Okay, the range, well, if you look sine and cosine, we're both stuck between -1 and 1. Okay, the y-intercepts between 0 and 360 for sine. Well, sine had a y-intercept at 0, 0. Cosine had an intercept at 0, 1. The x-intercepts for sine were 0, 0. And then I had one at 180, 0. And then I had one at 360, 0. For cosine, my x-intercepts were at 90, 0, and 270, 0. Okay? Degrees before the pattern repeats, well, that's 360 degrees. And hopefully you got that from the whole terminal arm swing, right? One revolution is one pattern. Okay? Max or mins, well, maxes are both 1, and the mins are both -1. Okay? And then the last part said use a calculator to solve for sine theta equals 0. So here you'll only get one answer. Okay, this is where I was saying, like, your calculator is dumber than you. It can only output one answer to you, whereas with our brains, we can think of many. If you use the graph to solve, well, how would that work? Well, okay, if I graph, 1, 2, 3, 4, right? If I draw a really sloppy graph of sine, so that's 90, 180, 270, 360. So I'd have this, right? Again, your graphs don't have to be nice. Like mine, this one is ugly, but I mean, like, it gets the point across, right? That's 360. So when is sine theta equal to 0? Well, when is my graph at 0? Here, here, and here. So most of you, if you solved this part on your calculator, you probably just got theta equals 0, which is right, but it's not complete, right? If you use the graph, you realize that there are 3 answers. Theta equals 0, theta also equals 180, and theta also equals 360. So that's why when we talk about which is better, the graph is better. okay? Because from the graph, I can see there are 3 answers, whereas the calculator does not give me the complete picture, all right? So I think that's it. So yeah, so like anything else, let me know. Hopefully take it easy, and we will talk to you guys soon. Okay, bye.